All right, I'm back, and in this video, we'll look at something. It's actually an extension of the last type problem we did. Here we're going to, and I went ahead and wrote out some notes here. We're going to compare two population means with estimated population standard deviations. And in chapter 11, your textbook authors delve into some of the theory related to the pooling of variances and so forth. And this is more of a practical type course as opposed to a theoretical course. So I'm not going to delve too deeply into the theory. But as the textbook authors point out, is typically when we're comparing two independent groups, typically we do not know what the population standard deviations are. Okay, every now and then we might, if it's say, let's say we're looking at standardized exams or something like that. But in the business world, just in in pretty much all walks of life, when you're looking at data, you do not know what the population standard deviation is. So what you end up having to do is we're going to use sample standard deviations as our best estimate of the unknown population, which brings us to the comparison we're going to do in this video. Again, we're going to compare two population means. We're going to have to estimate the population standard deviations because the population standard deviation is unknown. So we've got to make three assumptions here. First of all, independent samples. And here we simply mean that the performance of one group has no bearing on the other. And maybe the best way to think of or to describe independence is to describe what dependence would be. And there, for example, let's say you had a married couple. Let's say you had a husband and wife and asked them on a scale of 1 to 10, how would they rate the quality of their relationship? And if things are going well, we would assume that both of them would rate it pretty highly. If things are not going so well, then they would both be rating it lowly, but they're both observing the same phenomenon. Okay, so there will be a sense of dependence there. Here we're going to look at independence. An example would be the return on assets of bank A compared to the return on assets of bank B. Okay, something along those lines. So we're going to assume independence there. We're going to, again, assume that the population standard deviations are unknown. And in the textbook, they say that the standard deviations have to be equal. Uh, Actually, what it's got to be is they don't necessarily have to be exactly equal, but they cannot be significantly different from one another. Okay, and again, as have we um, talked throughout the past couple of modules here, anytime the population standard deviation is unknown, then we must use the t-distribution. And I know you guys can read, so be sure to pay close attention to the material. You got the last 3 or 4 lines here on page 377 to the top of 378. And pretty much they tell you, they go over pretty much why we need to pull the variances. Okay, so I'm going to trust you guys to take a look at that. Again, I'm not overly concerned about the theory, but I want you to understand at least a little bit of why we're having to do this. Okay, so what we're going to do is we're going to have to pull the variances. Okay, so we're going to have a pooled variance equation, and we've got this right here. It's going to be equation 11.4 on page 378. And what you end up doing is you pull the variance, you get the answer here, and then you insert it into the t equation here. And I'm going to go through an example of doing this. But again, all of this with the pooled variance, once we calculate that, it is inserted to this t formula as the pooled variance. Again, S squared is the variance, the P denotes that it is pooled. So I'm going to give an example here. We'll have the example of, let's say, a weight loss program. And we're looking at two, let's say Jenny Craig versus shots or whatever the case may be. But what we're going to ask here would be in terms of weight reduction, is plan A superior to plan B? And again, we're going to assume that the population standard deviation is unknown. And if plan A is superior to plan B, that means that you're going to lose more weight with plan A. So our alternative hypothesis would be that the mu, or the mean of A, is greater than the mean of B. The null would be that the mean of A is less than or equal to the mean of B, and we're going to assume a level of significance of 0.05. And we have the data for the two plans. Relatively small sample sizes here. We've got 14 participants in a study involving Plan A. The average weight loss was 18 pounds with a sample standard deviation of 4 pounds. Again, we're going to use this sample as our best estimate of the unknown population standard deviation, but by doing that, we've got to pull the variances. Under Plan B, they're losing a little less weight. I'm sorry, a little less weight. There are 12 participants, 15 pounds as opposed to the 18. A little bit more variation over at Plan B, 5 pounds as opposed to 4. So what we want to do next is we've got to pull the sample variances. Okay, and up here I've done that. This is the equation. It looks a little intimidating, but actually it's pretty easy. All that we're going to say is the N1, this is the number in group 1 minus 1 times the variance of group 1 plus the sample size of group 2 minus 1 times the variance of group 2 over the sample size of 1 plus the sample size of 2 minus 2. Now, technically, this is N1 minus 1 plus N2 minus 1, but that is the same thing as N1 plus N2 minus 2. So here for group A, we had 14 participants. Make sure that's right. Yep, that's right. So we're going to subtract the 1. The standard deviation was 4. We got to square that to get the variance. Okay, plus 12 minus 1 times 5 squared over the 14 plus 12 minus 2. So we end up getting 13 times 16 plus 11 times 25 over the sample size minus 2. So it's going to be 14 plus 12, 26 minus 2 yields 24. And we get a final answer of 20.125. And again, all that we want to do here is we're going to include that in the pooled variance part of this T equation. So for T, we're going to take the mean of group 1 minus the mean of group 2. Essentially, we're saying is this average weight loss difference of 3 pounds, the difference between 18 and 15, is it great enough to be deemed statistically significant, or is it small? We can say, hey, that's just sampling error. And what we've got to do is we've got to divide this by the square root of the pooled variance times 1 over the number of observations in group 1 plus 1 over the number of observations in group 2. And so 18 minus 15 is 3, and we're going to take divided by the square root of 20.125, that's our pooled variance, plus 1 over 14 plus 1 over 12. As you can see, I carried mine out pretty far. You don't have to carry it out quite that far. Do understand the farther you carry these out, the more accurate is your answer. You all can just follow ahead here. Carry this on out, just work through this, and you should come up with the calculated T statistic of 1.699. Okay, so almost 1.7. Now, what we're going to do is we're going to go to T, go to your T distribution. Okay, the number of degrees of freedom will be the number in group 1 plus the number in group 2 minus 2. So this is going to be one tail test, 24 degrees of freedom. You should come up with the calculated, you should come up with a T critical value of 1.711. I've got a little dot there to notice that we're at 1.699. Man, we're close. Okay, but hey, it's sort of like a football game. You can either lose by 30 points or you can lose by 1, but you still lose, okay? So we either reject or fail to reject. Okay, it's a binary decision. So in this case, because we are not in the critical zone, we fail to reject. So we would say that there is no difference between the two weight loss plans. Okay, again, that's how to do this longhand. Most of what we're doing is involving Megastat, but I think it is good to be able to work some of these out by hand. I know some of you, maybe it's been a while since you've taken the stats class, and maybe you haven't done much of this lately. So just gives you an opportunity to refresh yourself with that. So that concludes this video.